what we are going to practice doing is rewriting this in vertex form. Standard form, vertex form. Now, what is, based on our warm-up, what is something you guys noticed on vertex form? What is like, how is vertex form kind of related to what you guys did for your warm-ups, which I erased? Anybody, do you guys remember what were all the answers to your warm-up? They were all binomial squared, right? Do you guys see how vertex form is a binomial squared? So this is in standard form, ax squared plus bx plus h. Vertex form, I don't know why I got h, is a binomial squared, correct? So that means it is some binomial, like factored, right, as a binomial squared. Now, those are all perfect because those are what we call binomial squared can only be factored when you have perfect square trinomials, which at the beginning of class we said only occurred when the first term was a square and the last term was a square, correct? OK. Is this equation, is that a perfect square trinomial? No, right? So the process of completing the square is actually creating a perfect square trinomial. All right? So there's a couple ways we can do this. First of all, x squared is good, though, right? This 5 is not good. So what I'm going to do is I'm going to say, I'll keep x squared and 2x. But 5, you're going to go on the outside. So with x squared and 2x, I need to create a perfect square trinomial. So if you guys remember, the middle term was the first and the last terms being multiplied by 2. Do you guys remember that? It was like x and y and then times 2. So what I need to do to create my perfect square trinomial, I'm going to take b, divide it by 2, and square it. So in this case, I get 2 divided by 2 squared, which equals 1, squared, which equals 1. So what I'm going to do with that term is I'm going to say y equals x squared plus 2x plus 1. And then just remember, guys, whatever you do on if you do something on one side of the equation, you have to do it on the other side of the equation. But would you guys agree with me? If I add 1 over here, I could also just subtract 1 on both sides too, right? You could add on both sides, or you could add and subtract. It's really the same thing. Do you guys agree? OK. So for the sake of this type of problem, I'm just going to add and subtract on the same side. Now, look what I have here. Did we do one of those? Oh, we did one close. This is something we can factor, correct? Yes? So all we're simply going to do is now this is a perfect square trinomial. Why is it a perfect square trinomial? Because we created it. It has to be, because we created it. That's what b divided by 2 squared does, is it creates a perfect square trinomial. So now we have y equals x plus 1 squared plus 4. Vertex is -1, comma 4. And since my graph opens up, it is a absolute minimum.